Databricks has become one of the most important platforms in modern data engineering and analytics. Its Lakehouse platform unifies data warehousing, machine learning, and AI workloads under one architecture, combining the best of data lakes and data warehouses. But beyond its flexibility and performance, what makes Databricks truly enterprise-ready is its security model, built to handle data at scale while ensuring compliance, privacy, and governance. This article provides a clear, beginner-friendly overview of how the Databricks Lakehouse architecture works, and how its security features protect data across ingestion, storage, and compute layers. Traditionally, organizations used separate systems for different workloads: data warehouses for structured, analytical queries, and data lakes for raw, unstructured data used by data scientists and engineers. This split caused inefficiency, duplicated data, complex ETL pipelines, and inconsistent governance. The Lakehouse concept solves this by merging these two worlds. A lakehouse stores all data in a data lake, but adds data warehouse-like features such as schema enforcement, governance, ACID transactions, and performance optimizations. Databricks operationalized this concept by building a unified platform where you can store data efficiently using Delta Lake, analyze it using SQL, Python, R, or Scala in collaborative notebooks, and train and deploy machine learning and AI models on the same data. At its heart, the Databricks Lakehouse platform is built on three foundational layers. The Delta Lake is the backbone of the Lakehouse. It sits on top of cloud storage systems like AWS S3, Azure Data Lake Storage, or Google Cloud Storage. Delta Lake introduces key data management capabilities: ACID transactions, schema enforcement, time travel, and scalability. With Delta Lake, your data lake becomes structured and reliable enough for advanced analytics and BI workloads. No need to move it to a separate warehouse. The compute layer is where your data transformations, queries, and machine learning workloads run. Databricks provides a managed Apache Spark environment called Databricks Runtime, optimized for speed, stability, and integration with Delta Lake. Each workload runs inside clusters, which are elastic, automatically managed compute resources. Clusters can be interactive clusters, job clusters, and high concurrency clusters. Databricks automatically handles scaling, caching, and termination, so teams can focus on logic rather than infrastructure. On top of storage and compute, Databricks adds a governance and collaboration layer: Unity Catalog, notebooks and repos, and Delta sharing. This architecture transforms Databricks into a single source of truth for analytics and AI, a key goal of modern data ecosystems. Security is a first-class concern in Databricks architecture. Since the platform operates across multiple cloud providers, it adopts a shared responsibility model. Databricks secures the platform infrastructure, while customers manage data access policies and configurations. Databricks integrates with the cloud provider's IAM service. This allows single sign-on and role-based access control across workspaces. Users and groups are synced from your organization's directory. Workspace roles control access to clusters, notebooks, and jobs. Data access roles enforce permissions at the table, column, or row level via Unity Catalog. Unity Catalog's fine-grained governance allows administrators to specify policies like analyst can read only the sales table, or data scientist can write to the experiment's schema but not delete. All data in Databricks is encrypted by default. At rest, data stored in Delta Lake is encrypted using cloud-native encryption. In transit, communication uses TLS 1.2 or higher. Enterprises can bring their own encryption keys for maximum control. This ensures compliance with regulations like GDPR, HIPAA, SOC2, and ISO 27001. Databricks offers multiple layers of network protection: private link/private endpoint, VPC peering, and cluster network isolation. Admins can also configure firewall rules, IP allow lists, and secure inbound/outbound traffic policies. Clusters, the compute engines, are sandboxed and isolated. Credential pass-through, no persistent state, and table access controls. Admins can enforce cluster policies, for instance, requiring encryption, disabling internet access, or restricting cluster creation by role. Databricks provides detailed audit logs for every user action, from login events to data modifications. These logs can be exported to your CM tools like Splunk or Azure Monitor to support compliance and threat detection. Administrators can track who accessed what data and when, which jobs or queries ran, configuration changes to workspaces or clusters. Through Unity Catalog, Delta Lake, and audit logs, Databricks simplifies compliance for standards like GDPR, HIPAA, SOC2, and ISO 27001. Built-in data lineage in Unity Catalog tracks the full history of how data was transformed, ensuring traceability and accountability, a critical requirement for regulatory audits. When combined, the architecture and security of the Databricks Lakehouse platform deliver a balanced mix of scalability, performance, and protection. Delta Lake ensures data integrity. Databricks Runtime ensures speed and flexibility. Unity Catalog enforces governance. Encryption, IAM, and logging ensure enterprise-grade security. Together, they create a unified environment where analysts, engineers, and scientists can safely collaborate on massive datasets without compromising compliance or trust. The Databricks Lakehouse platform represents a paradigm shift in data architecture, merging the openness of data lakes with the reliability of data warehouses. Its security model ensures that even as organizations democratize data access and accelerate AI innovation, their information remains fully protected. By integrating governance, encryption, network isolation, and identity management into every layer, Databricks proves that speed and security can coexist. In a world where data breaches and compliance risks are rising, the Lakehouse model offers not just performance, but peace of mind, the foundation of a truly modern data platform.